In section 3.1, we are introduced to functions and function notation. Let's talk about the definition of a function. A function is a relation in which each element in the domain, which are the inputs, correspond to exactly one element in the range, the outputs. In other words, any given x value can have only one y value. Okay, so for example, determine if each relation represents a function. If it's a function, state the domain and range. So in the first case, and what I'm going to do is I'm going to make a little chart here. So I have my x values and my y values. So my first point is 1, 3. So 1 is paired up with 3. We have 0, 5. We have negative 5, 2. We have 1, 8. Now notice what's happening. 1, it's paired up with 3, but it's also paired up with 8. So the input of 1 has an output of 3 and has an output of 8. And then we have our last one, which is 10, negative 5. The definition is each element in the domain, the x values, can only have one element in the range. So each x can only have one y value. But x equals 1 has two separate y values, 3 and negative 8. So the same input has two outputs. Therefore, this is not a function. Let's take a look at the second one. I'll make the table over here. So we have 7, 1. We have 2, negative 8. We have 6, 0. We have 4, negative 3. And we have 5, negative 5. Now, every single input, every single x value is paired up with only one y value. So each input has only one output. Therefore, this is a function. And the domain is a set of all x's, and the range is a set of all y values. So our domain and range are given by set notation. So we have the set 7, 2, 6, 4, and 5. So the domain is a set of all x's, and the range, it's 1, negative 8, 0, negative 3, and negative 5. Another example, we got the name of the person and their significant other. So Andy's significant other is Kyle. Sam has two significant others, Blake and Amy. So the same input has two different outputs. Therefore, this is not a function. To determine if a graph represents a function, we use the vertical line test. Here's how that works. You draw a vertical line, and if each vertical line intersects the graph only once, then it is a function, because it means that any given x value, any input, has only one output. But let's take a look at this case. Here, this vertical line, it intersects the graph twice. And what that tells us is that whatever this input is, that x value, it has two different outputs. So when a vertical line hits a graph more than once, it is not a function. Same over here. This vertical line hits the graph more than once, therefore it is not a function. Hits it here and hits it here. Therefore, this is not a function. So this input, whatever that input is, it has two different outputs. Output number 1 and output number 2, making this not a function. Now, a function is a one-to-one function if it goes both ways. In other words, each x can only have one y, and each y can only have one x. So every x is paired up with exactly one y, and every y is paired up with exactly one x. That makes a one-to-one function. For example, we have 2, negative 3, we have 4, 7, we have 5, negative 8, and we have 10, negative 3. So every x can only have one y. So let's see if it's a function. So each input has exactly one output. But the other way has to also be true, that every y can only be paired up with one x. But negative 3 is paired up with two different x values. Negative 3 is paired up with 2, and it's also paired up with 10. Therefore, this is not a one-to-one function because -3 has two different x values. Determining whether a function is one-to-one graphically. If a function is one-to-one, its graph will pass both the horizontal and the vertical line test. So let's take a look at this example. This graph passes the horizontal line test because any horizontal line you draw is going to hit the graph only once. That makes it a function. But if we draw vertical lines, like this one, like this one, like this one, every vertical line is also going to hit the graph exactly once. Therefore, this is a one-to-one function. This one, however, if I draw a vertical line, it hits the graph twice, which means the y value of 2 has two different x values, -2 and +2. So we have -2, 2, and we have +2, 2. Because the same y value has two different x values, this is not a one-to-one function. Okay, so quick recap. For a function, you have to pass the vertical line test. A vertical line can only hit the graph once. If it hits the graph more than once, it is not a function. To go one step further, if it hits the graph, if a horizontal line hits the graph once, then it is a one-to-one function. But if a horizontal hits the graph more than once, then it is not a one-to-one function. Okay, so I'll put a little summary here. The vertical line test determines if a graph is a function. The horizontal line test determines if a graph is a one-to-one function. If the vertical line test is passed, it has to be a function for it to be a one-to-one function. Given a graph, let's find f of 2. So here's function notation. Function notation is f of x equals to y. This is the input or the x value, and this is the output or the y value. The parentheses always contains your input. Okay, let me repeat that. The parentheses contain the input or the x value. So if we're given f of 2, it means we have an input or the x value of 2. So we have our x value of 2, and we just have to find the corresponding y value on the graph, which is -1. So the output is -1, which means f of 2 is -1. So when the function has an input of 2, the x value of 2, its output or the y value is equal to -1. Parentheses always contains the input, and that equals to the output. Solve f of x equals to -2. So this time, here's what we have. We don't know what our input is, but we know our output is -2. So in other words, our y value is -2. So let's find a y value of -2, which is right there. That's a y value of -2. And let's go to our graph and see what the corresponding x value is. When the y value is -2, this is the point on the graph, which is a point 6, -2. So when the output is -2, the x value equals to 6. Because a point on the graph, this point right there, is the point 6, -2. So if you're given a value inside the parentheses, that is your x or the input. If you're given a value outside, that is your output or the y value. Next one, solve f of x equals to 1. So let's find if the 1 represents the input or the output. So we know that the parentheses always contains the input. So our input is x. That means the result is the output, which is 1. So a y value is 1. This is the y value of 1. Now for a y value of 1, let's go and find the point on the graph, which is that point. And the corresponding x value is -1. So x equals to -1. And that point is the point -1, 1, which has a output or y value of 1. Next example, evaluate f of 2. Once again, the parentheses always contains the input. So our input is 2, which means our x value is 2. So on the table, let's find the x value of 2, which is right there. And the corresponding output is 4, so f of 2 is equal to 4. And the point on the line, or point on the table, is 2, 4. Next, let's solve f of x equals to 22. The parentheses contains the input. I'm going to keep saying that over and over again so we don't forget. The parentheses contains the input. So the input is x, and the output is 22. So we want to figure out where is a y value of 22. So these are the y values, the outputs. 22 is right there. And the corresponding input is 4. So x has a value of 4, which means that f of 4 equals to 22. Lastly, let's solve f of x equals to -1. The input is in the parentheses, so we don't know what the input is, but we do know the output is -1. Output is the y value. Let's find a y value of -1, which is right there. The corresponding input is +1. So the x value, or the input, is going to be 1, and when the input is 1, the output is equal to -1. Evaluating functions. So given the function f of x equals to 5x squared minus 9x plus 4, we want to evaluate f of -3. So our input, or the x value, is -3, which means every single time we see an x, we replace the x with the input, which is -3. So you replace the x with whatever is contained inside the parentheses, because that is your input. So here we have 5 times -3 squared minus 9 times -3 plus 4. Order of operations, PEMDAS. So parentheses, we have a parentheses, but it's simplified. So now we go to exponent. We do the exponent first. -3 times -3 is +9. -3 squared is -3 times -3, which is a +9. So we have 5 times 9 minus 9 times -3 plus 4. One step at a time. So in this step, we only do the exponent. Then we can multiply. So 5 times 9 is 45. -9 times -3 is 27. And then you have plus 4. So if you add 47 plus 27 plus 4, I believe that will give you 76 as the answer. You can also put this in your scientific calculator just the way it looks, and it'll give you the exact same answer. Okay, let's do the next one, f of 2. So f of 2, and for proper notation, I'm going to write f of -3 equals to 76. So that means when the input is -3, the output is 76. F of 2, so the input is 2. We have an input of 2. Our x value is 2. So we're going to have 5. Instead of x, we have a 2 because our input is 2. The x always gets replaced with the input. So we have 5 times 2 squared minus 9 times 2 plus 4. 2 squared is 4, so 5 times 4 minus 9 times 2 plus 4. 5 times 4 is 20. 9 times 2 is 18. 20 minus 18 is 2. 2 plus 4 is 6. So f of 2 equals to 6. In other words, when the input is 2, the output is 6. Next, let's take f of -3 plus f of 2. Well, we know what f of -3 is. F of -3, we calculated that to be 76. So when the input is -3, the output is 76. We know what f of 2 is. That's equal to 6. So when the input is 2, the output is 6. And so we have 76 plus 6, which equals to 82. Okay, the last example we will do in class. But just remember that we need to separately find out what is f of 1, and then find out what is f of -4, then subtract the numbers at the end.